Basic idea here is we want to have communication between a IoT server, which for us is a Raspberry Pi, and a remote Arduino, and we're using Xbees to do it. If you wanted to, you could get rid of the Xbees and just connect the Arduino directly to the Raspberry Pi. I'll post another version of the code that does that. We're using Express and we're using Socket IO to keep state between our front and back end. Let's look at the code here. Now I have it running. Let me do a Control-C. We'll clear this. You'll need to do an npm install. So download the code, switch to the Pi folder. I'm on my Pi through PuTTY. Do an npm install, and then you can do an npm start, and you'll get your server up and running. Now, once your server's up and running, you can just refresh both of these. You'll notice immediately it shows you the state of whatever the LED is. And if I toggle it, all of your clients will stay in state. And Socket IO is doing that for us. Let's look at the code. 3 basic files that you need. You'll need your CPP file. If you're running it on using the Arduino editor, it'll be at INO. Is that what Arduino is? But what you'll need to do is just copy everything but this first line, and you can paste everything right into Arduino, and it would run just fine. We're using software serial, and the reason is I wanted to, if we go to images here, I wanted to leave the default serial, so RxTX, open for serial debugging in the Arduino. So you'll notice that I have a software serial set up. So Rx here on the Pi goes to TX on the Xbee, and then Rx on the Xbee goes to TX on the Pi, and that's just how I have it set up. You could take these two and move them down here. So 2 would go to 0, 3 would go to 1, and then you're just using regular serial. You wouldn't need software serial. We have ground, we have pin 7, and we're using pin 7 to toggle the state of the LED. And you'll notice I also have DIO 0 on the Xbee connected, and it's reading the digital state of pin 7. And that way it can report back to the Raspberry Pi what the state is, and then we can use Socket IO to keep the web page in state. All right, let's close that up. Not too much exciting going on. I have the bare bones version of the Xbee code. There's lots of examples that come with the Xbee library, so check it out. But what you'll notice here is I'm really just listening for a single byte, so I'm sending a 7. Now, I'm sending a 7 only because I'm toggling pin 7, but it really could be anything that you want. You just have to look for that. But it seemed to make sense to send a 7. Now, we send it in hex, and I'll show you that once we get to app.js. So 37 would be a hex version of 7. And then we look for it here as a 55. If you wanted to, you could have an else if and look for, get data 0, 56. And let's say that we're using that for pin 8. And then toggle pin 8 or something like that. You could also send more than a single byte. You would just have to iterate through everything inside of get data, and it has a length property, so you could iterate through the whole thing. All right, that's it. That's pretty easy. Nothing to change here. You can just paste this right into your Arduino, get it set up, and it'll work fine. All right, app.js. Let's see here. We're using Express. We're using it a little bit differently. We're not listening directly on app like you would normally do with an Express app because we're using Socket IO. So take a look at Socket IO's website. There are many examples out there using IO and Express together. If you're serving up, or if you're running your app from a www folder in a more if you used the Express generator or something like that, you'd have to do a little bit of research on using serial IO with your startup scripts and how that would work. I have this line just because I'm serving my index HTML from public. I have this line because I wanted an alias for JS, because I'm going to serve my Socket IO client library I'm going to serve it up locally so I don't have to use the CDN. And that way everything works just fine if I have no internet. Every time a client connects, we send them an update of the pin state, and there's just an in-memory JavaScript object. Here we're listening for state change from the client. So the client hits the button and we send an update server with the pin, and then we can call toggle pin. Toggle pin is just listening for the pin number, and we have a hard-coded frame. Here's our 37, so we're sending a 7 over to here, and again, but here we're listening to it as a 55. If you wanted to, you could send, and I'll post another video, but you could send more than just this single byte. Maybe you're trying to send a hex triplet or something to set color, or maybe a message. In that case, you'd have to build this on the fly, and you'd have to create your own checksum, and I have the code to do that. And again, I'll show you that in another video. And you were all set up if you wanted to also, change this so you could toggle pin 8. Basically, this would have to be a 38, and you would have a new checksum. Okay, and then we just write it. You probably want to defend against data being undefined, but we write that out. Here we're connecting to the serial port on a USB connection between these two. And if you want to know what COM port you're using, then you could just run this line. So run this line in a terminal on your Xbee with the without this connected, without your Xbee connected, then run it with, and see which port it's plugged into. Here's our in-memory object right here. We just have the single office, which is this, which is that Xbee right there. And we can listen for multiple types of frames. So 146 is the I/O sample data that's coming through, and I'll show you that in a second here. And I'm listening for this radio, which is the 64-bit address of this radio. This is really the only thing you would need to change. You'd need to change that to the 64-bit address of your radio. It is case sensitive, so lowercase letters. Or you could handle that by using .equals and such, and you could do a search on JavaScript and doing case insensitive comparisons. But for this purpose, just use lowercase letters and you're good to go. So what we do is we have a frame come in, and we check the digital samples. And if we look right here, we're checking these samples. So right now DIO is set to 0, DIO1 is set to 0. And DIO7 is set to 0. We're only using pins 0 and 1, so that would be the first 2 pins here. The first one I have set up to the LED, and then the other one I just have set up to a little reed switch here. And it's a very simple reed switch setup. It doesn't handle debouncing. It doesn't handle a sleep state on the Xbee radio, but if it's disconnected or let's say open, it's returning a 1. And if it's connected, it's returning a 0. So we can watch for that. Now I'm not handling that on the other side. You guys could deal with that. And my connection is very simple. I have one connection to ground, and then I have the other line running to DIO1. And again, we can just see whether that's open or closed. All right. And then we just emit. So if these are not equal, meaning I got a different state, we emit that change. And we only want to emit on state change, so we only want to send the lighters on if it's off, or vice versa. But if you had multiple Xbees coming in, you could then have something else. Maybe you're setting this up to drive garage doors or something like that, right? So you could add something else there. All right, so lastly, we have index.html. And it's pretty easy. I have a little bit of styling going on. You should probably push this into a CSS folder. We have a single button. ID is lamp or LED, whatever you'd want to call it. Here is that alias that I talked about. So that was this line right here. Otherwise, if you don't want to, if you just want to use the CDN, you could put the CDN address right here. Socket.on update client. So every time I get an update, so that is what? That's this line, right, being emitted. Every time that comes in, what I do is I check DIO 0. If it's 0, then I set the lamp text to off, the button text to off, and I set the color. If it's on, then I set it to right, and otherwise this would be a 1. In that case, I set the text to on, and I set the color. And we're just using the ternary operator, a shortcut for if-else. So we're saying if this, do what comes after the question mark, else do what comes after the colon. And then lastly, if somebody clicks the button, we emit an update with a 7. And in that case, we're coming right here. In that case, we're coming here and we're going through that process that we already looked at to send the data. Now we could also, give me 1 second here. Okay, so here is a different version, and again, I'll post this code as a different Git repo and then as a different video, but this one isn't running locally. So we're using Dataplicity here, and you'll notice that what we can do is you can choose a color and then choose to set the state of remote RGB LEDs, and I'll show you how you can do that also. So instead of just doing a simple toggle, of a state, you can actually send hex triplets in this case back and forth and understand what the state is. And this is waiting for a response to come back from the remote radio. All right, so I think that was everything here. There's I put some posts. So this gentleman does a great job. If you've never set up Xbee Radios before, he does a good job showing you how to set them up in API mode. Once you do that, the only thing you would need to do is make sure that you have pin 0 set to digital input. So you're going to read, and this is where we're reading the input of pin 7 on the Arduino. And you can set your IO sample rate to be, in this case, that's hex for 1,000 milliseconds or 1 second. If you haven't put Node on a Raspberry Pi, this gentleman does a good job. And I originally, when I was trying to figure out how to get Node on a Raspberry Pi, I used his tutorial here, and he does a good job. All right, good luck.